Now we're going to be talking about polar bonds in molecules. Nonpolar covalent bonds are covalent bonds in which electrons are shared equally by the two atoms. A polar covalent bond, also known as a polar bond, is a covalent bond in which the electrons are shared unequally. The more electronegative atoms attract electrons more strongly and gains a slightly negative charge. A less electronegative charge would have a slightly positive charge. The Greek letter for delta is also involved in the equations for covalent bonds. Delta denotes that atoms involved in covalent bonds only Like I was saying, delta denotes that atoms involved in covalent bonds only partial charges, less than 1 plus or 1 negative, as shown in the example below. The negative sign shows atoms have acquired a slightly negative charge, while the positive sign shows the atom has acquired a slightly positive charge. Another way to write the model showing the polarity of the two atoms would be by drawing an arrow over the equation and turning the end closest to the positive atom into a positive sign. Another example would be the H2O molecule, and looking at the polarity through the graph of this. Again, you could write it this way, or you could write it with the arrows and put the positive end over the, not over the dog, but over the hydrogen. In a polar molecule, one end of the molecule is slightly negative and the other end is slightly positive. That is different from a dipole, which is a molecule that has two magnetic poles. When polar molecules are placed between two oppositely charged plates, they tend to become oriented with respect to the positive and negative plates. Here you see molecules with both positive and negative ends, and they're all just about jumbled around, facing whichever way they want to face. Now put one positively charged plate on one side and a negative charged plate on the other side. And then the atoms move around so that you have the positive ends of the atoms facing the negatively charged plate and the negative parts of the atoms facing the positively charged plate. The effect of polar bonds on the polarity of an entire molecule and the orientation of the polar bonds. Oh, okay, I see my error in my writing. I was supposed to write the effect of the polarity on the polarity. The effect of polar bonds on the polarity of an entire molecule affects the orientation of the polar bonds. Intermolecular attractions are weaker than the ionic and covalent bond. And van der Waals forces are named after the Dutch chemist, and it states that the two weakest attractions are weaker than either ionic or covalent bonds.